Hi class, I thought I'd make another video of the same stuff we reviewed today in class. I hope it helps some of you who are absent. This problem is in your notes, so you can follow along in your notes. I recommend that you pause the video and make sure you know where these numbers came from. So this question says, calculate the percent by mass of water for this hydrate. This hydrate is called iron 2 sulfate heptahydrate. What we want to do here is get the molar mass of both parts, the iron 2 sulfate and the 7 waters. I recommend that you verify these numbers on your periodic table. Okay, for the iron 2 sulfate, that molar mass is 151.92. For the 7 waters, I want to do 14 times 1.01. That's for the hydrogens, 7 times the oxygens. Alternatively, you could do 7 times the molar mass of 1 mole of water, so 7 times 18.02. You'll get the same answer. Now I want to add the two molar masses together, 151.92 plus 126.14. That comes out to 278.06. To find the percent of water, we're going to take our number for water, divided by the total, times 100 to make it a percentage. Comes out to 45.4% water. There's another sample in there. If you want to check your work for that, you can go online, and I posted the slides. If you scroll down a ways to the notes and slides, you'll see it there. Now here is an example of a hydrate question. 3.91 grams of copper 2 sulfate hydrate was heated. 2.50 grams remained. What is the formula and name of the hydrate that was formed? This question is a lot like what you did in the lab. What we're going to do is compare the moles of the anhydrate, in this case it's copper sulfate, and the moles of water. So to find the moles of water, first we have to find the grams of water. You subtract 3.91 and 2.50, you get 1.41, and that's grams of water. Now you know how to go from grams to moles. You just divide by the molar mass. In this case, it's 159.62. When you crunch that number, you get 0.0156, and that's moles of the copper sulfate. Okay, you do the same thing for water. We're going to divide by the molar mass there. It's 18.02. You crunch the number there, you get 0.0782, and that's moles of water. Now to find the formula of the hydrate, we want to know how many molecules of water for each formula unit of copper 2 sulfate. So what you do is you take the number of moles of water, you divide it by the number of moles of copper 2 sulfate. That's going to give you approximately 5, which is good. You got very close to a whole number, which means we're on the right track. It means that for every 1 mole of copper 2 sulfate, you had 5 moles of water. And that is the formula of the hydrate. To name this, it's just like naming other ionic compounds. We have copper 2 sulfate. That was Kaya yawning, not me. And for the 5 waters, we're going to use a prefix for 5, which is penta. and hydrate. There you go. I recommend you try the other practice problems in the study guide. Now I want to do one more problem from the textbook, which includes the mass of the crucible. This question is number 154. It gives you a data table for a hydrate lab. You can see that you have mass of the empty crucible, mass of the hydrate plus crucible, and you're asked to find the initial mass of the hydrate. So all you do there is you subtract. You got the mass of both minus the empty crucible. You get 10.05 grams of the hydrate. And your data table also says that after 5 minutes of heating, the mass was 29.87. If you subtract out the weight of the crucible again, you're going to get 8.57. Okay, and this is for the anhydrate, which in this case is barium chloride, BaCl2. That's grams. All right, so from here we can find the grams of water if we subtract our hydrate and we're subtracting the solid. That's going to give us the grams of water, 1.48. Now from here, now that we have our raw data, from here we can calculate the moles of barium chloride and moles of water. It's supposed to be chlorine. That was messy. The molar mass of barium chloride is 208.23. That gives us 0.0412. Now if you want to change this to scientific notation, that's fine. It's not a problem. Now we're going to do the same thing with the water. Divide by the molar mass of water. If you've done enough of these problems, you probably have the molar mass of water memorized. I know it's boring, right, Kaya? You're yawning, aren't you? Okay. So we want to find the ratio between the barium chloride and the water. So we're going to put the number for water on top, the number for the barium chloride on the bottom. You're going to get about 2. So that means that for every 1 mole of barium chloride, you had 2 moles of water. You always want a whole number. If you get less than 1, that means that you either calculated the moles wrong, or you put the water on the bottom instead of the top. So for the formula for this hydrate is BaCl2 dot 2 H2O. The name for this is barium chloride dihydrate. Okay, I want to do one last quick practice problem with you on percent composition. Let's, for example, say an easy one, carbon dioxide. If we want to know the percent composition of carbon dioxide, we want to find the molar mass first. .01. If we want to find the percentage for carbon, we take all of our carbon atoms divided by the total times 100 to make it a percentage. 27.289, so we're going to do 27.3% carbon. To find the oxygen, everything else is oxygen, so we can subtract 23.7 from 100. That gives us 72.7% oxygen. There's lots of practice problems on the back of the vocab. You can find all of the questions online. I put pictures up of the textbook. All right, good luck.